Number 13, the sauce bottles are similar with height as shown. The smaller bottle has a label area of 50. So this is 50 centimeters cubed. This section in here, the blue section there, is 50 centimeters cubed. Okay? And what we're going to have to find out is what is the red section here. Okay? So what we first do is we compare the scale factor. The blue one is bigger, the one on the left is bigger than the one on the right. So you're going to do 24 divided by 20 to find out what K is. So what is K?
6 over 5.
6 over 5. Now, key word here is area. Area is not affected by the scale factor. It's affected by the scale factor squared for 2 dimensions. Okay? So what's K squared? It's going to be 36 over 25. Because K is 6 over 5, K squared is 36 over 25. Shh. Now lads, if this one's 50 centimeters, it's going to be divided by 36 over 25. You want a smaller answer than 50. So what is 50 divided by 36 over 25?
72 centimeters. No, never mind.
No, you got it upside down. So just, okay guys, 50 divided by 36 over 25. And we'll see what it comes out as. It has to be an answer smaller than 50 because it's a smaller bottle. 34.72. Okay? 34.72.
So smaller bottles are 50 centimeters, not bigger.
Oh, for God's sake. Alright guys, sorry. The smaller bottle is the one that's 50, not the bigger bottle. So guys, the smaller bottle is 50, the bigger bottle we don't know. But what we do know is it has to be 36 over 25 times bigger. So in this case we're going to multiply 50 by 36 and 2 over 25. The answer has to be a number bigger than 50 then. Okay? And if it's bigger than 50, the answer is 72. So this one here is 72, and this one here is 50. Sorry about the confusion. Just make sure we read it. Smaller bottle being this one here. Okay, guys? Number 15. The enlargement reading on a photocopier is 100% when the copy is the same size as the original. When the reading is 110%, then each length is increased by 10%. What enlargement region do you want to use if each length is decreased by 30? What would you say that is? I'd say 70%. Because if you increase it by 30, it's 130%. Therefore, if you decrease by 30, it should be 70%. B. An 8 centimeter line increased to 12 centimeters. So 12 divided by 8 is, anybody? 1.5. Now remember, 1 is 100%. So what do you think 1.5 is? 150%. Okay? If it's 1.5 times bigger, it's 150% bigger. If I said increase your size by 200%, you would actually be twice as big. Okay? Now guys, a 15 centimeter line reduced to 9. So it's going to be 15. Sorry, it's the original. The new one divided by the original. The new length divided by the original. So it should be 9 divided by 15. So what's that? 9 divided by 15. Put it in fraction mode and then multiply it by 100. 0.6 multiplied by 100. It's 60%. Now guys, the confusion will come in here, Keane, okay? The confusion is, it's always the new size divided by the old multiplied by 100 over 1. You might want to make a note of that in pencil. New divided by old multiplied by 100 over 1. Okay? Next one. Okay. The Ray method was used to design a large Valentine's card. The original is labelled A and the image is labelled B. Find the centre of enlargement. Okay guys, to find the centre of enlargement, it's very easy.
There's more on 15.
Was there?
4. Part 2, 3, 4, and 5.
ABC?
No, on the next page.
On the next page, okay. Alright guys, the shaded area on the original is 50 centimeters squared. What is the shaded area in the copy when the large ingredient is 120? Now what that means guys is, remember, keyword is area. You're looking for K squared. You're going to multiply by K squared. So guys, if it's 120%, it's the same thing as an enlargement of 1.2. But because we're dealing with area, you don't want 1.2, you want 1.2 squared. Find out what 1.2 squared is and multiply it by the original. So it's going to be 50 multiplied by 1.2 squared. And it's going to be 72. So it's going to be 72 centimeters squared. The next one is 60%. This time K equals 0.6. And now you're going to multiply 50 by 0.6 squared. Does anybody have that for me?
18.
So it's 18 this time around. Okay? Okay guys, that is part 2. Part 3, which we'll be doing in red. The ratio...
Is that 8 centimeters squared?
18 centimeters squared. Yeah. Okay. Yes, Andrew. Sorry.
It's over 60%, that's over half the size, so over 13.
Not too.
Continuing on. The next one is the ratio of 120 to 60 equals 2:1. Explain why answers in part 2 are not in the ratio 2:1. Okay. Part 2. Okay. The reason why the answers in part 1 aren't in the ratio 2:1. So what was the first answer again? The first answer was 50 multiplied by 1.2 squared. What was that? 72. Why is 72 and 18 not in the ratio 1:2 or 2:1? Now the reason for this is area is two-dimensional, and because area is two-dimensional, it is changed by a scale factor. It's changed by a scale of K squared, or a half squared. See the way 60 is a half of 120? That's a half squared, which is a quarter. Okay? Hence why 18 is a quarter of 72. It's two-dimensional, guys. Okay? That's why that happens. Alright, guys. What percentage to the nearest whole number would you use on the photocopier to double the size of the document? Justify your answer. Now, the question there is, am I doubling the size or am I doubling the area? I would write down both answers and say that the question is dubious. Okay? So example would be, to double the size, okay, what percentage correct to the nearest whole number would you use on the photocopier? Okay guys. What percentage correct to the nearest whole number would you use on the photocopier to double the size of the document? So to double it, if I had a 8x6 document, if I wanted to double that, if I multiply that by 200%, what I end up getting is 16 by 8. That doubles the size of the length and the... 16 by 12. It doubles the size of the length and the width. Okay? To exactly double the size of the document, a scale factor of larger than root K. What is the value of K? Justify your answer in conjunction with part 4. Okay? Well, to double the size of it, it will have to be a scale factor of 2. Okay? Now what is the square root of, if the scale factor is root K, we already know that the scale factor has to be 2. Yeah? This means that root k equals 2. What do you think k has to be? Anybody? What number when square root is the number 2? 4. So k is equal to 4. That doesn't mean the scale factor is equal to 4. It means whatever the hell they called k in this question is 4. K doesn't have to be the scale factor, it just usually is. Good. To do this one here, okay, find the centre of the enlargement. To find the centre of the enlargement, join the corners to each other and keep going. Then join this corner to this one, keep going. Join this corner to this corner, keep going. And finally this corner to this corner here. And it's where all the lines intersect. Now you can see that I'm slightly off with my drawings there, but it should be more or less around here. That is the point O, the centre of the enlargement. Find the scale factor of the enlargement, use your ruler and show your work. Okay. Well, you could use your ruler, but the measurements are already there. So there's actually no need to use your ruler. Because we know that the bigger one is 40 and the smaller one is 16 wide. So what's 40 divided by 16? 2.5, okay? So this one is 2.5 times bigger than the second one. And it goes, calculate the ratio of the area of drawing B to the area of drawing A. I'm going to show you how to do this two different ways. Method 1 is to multiply 16 by 20, and what do you get? 320. Method, and the second one is 320. 50 by 40? 2000. Jordan. Okay? So it's going to be 2000 divided by 320. What is 2000 divided by 320? Sorry?
25 over 4.
Okay, it's 25 over 4. So it's 25 over 4, and it's basically the ratio 25 is to 4. Now, was there any other way we could have got that? Remember, our scale factor is 2.5. 2.5 is 5 over 2. We also said that area is affected by k squared. What is k squared then? Square 5 you get 25, square 2 you get 4. So we could have found it that way as well. There's two different ways of finding it. Okay? Alright guys, last one of today, is it? 17. Was there anything after 17?